When you think of space exploration, images of astronauts bouncing on the moon or robots roving across Mars probably come to mind. But what if I told you there's a whole new frontier hidden in plain sight? It's the vast space between Earth and the Moon, and it's becoming the battleground for the next space race. Welcome to Cislunar Space. This seemingly empty space between Earth and the Moon, it's far from empty. In fact, it's poised to become the most valuable real estate in the future of space travel, exploration, and commerce. So what is Cislunar Space? Think of Cislunar Space as a cosmic superhighway, where spacecraft will zip back and forth between Earth and the Moon. But it's more than just a route for travelers. We're on the verge of building a web of infrastructure, satellites, space stations, even entire networks, that will power the future of human activity in space. Science, exploration, industry, it's all about to take off. Imagine building highways, rest stops, and service stations on your daily commute. But this time, it's all in space. Instead of asphalt, we're talking about space stations, lunar bases, and satellites. Welcome to the next chapter of humanity's cosmic journey. Why build in Cislunar Space? Our world thrives on technology. Data is the new gold. Satellites keep us connected, and scientific breakthroughs shape our future. But to push the boundaries of what's possible, we need to break free of Earth's limits. And Cislunar Space, that's the ticket to an unlimited future. Imagine you're venturing to the far side of the Moon, where Earth's signals can't reach you. You'd need a cosmic relay race of satellites to bounce your messages back home. The Moon's silence will soon be a thing of the past, as satellites blanket the space between. Just like how your phone connects to towers to keep you in touch, Cislunar satellites will ensure we stay connected, no matter how far we venture into space. NASA's Lunar Gateway will be a hub, orbiting high above the lunar surface, a cosmic layover where astronauts refuel, refresh, and launch their next great adventure. Nations and private companies are investing heavily in Cislunar Space. Picture it as an airport in space. Instead of a long-haul flight straight to the Moon, astronauts will stop at the gateway, check their gear, refuel, and then glide down to the lunar surface. It's not just efficient, it's the safest way to explore the Moon's untamed wilderness. It's not just about visits. We're looking at permanent lunar bases. Think space outposts where astronauts, scientists, and yes, even miners could call home. The Moon's bounty includes water ice, essential for drinking, rocket fuel, and life itself. Plus, there's talk of rare minerals, potentially worth trillions, that we could extract. Why bring everything from Earth when the Moon has resources right there for the taking? Imagine mining not for gold or oil, but for the building blocks of space exploration itself. Compare it to mining gold rushes on Earth, but now, the stakes are higher, and the ground is lunar. Of course, space is no walk in the park. In Cislunar Space, the stakes are even higher. Blazing radiation from the sun, icy temperatures, and even micrometeoroids threaten to sabotage our efforts. And that's before we even talk about the cost. But that's why the brightest minds are hard at work, building tech that can withstand the harshest conditions. The goal? To make space construction not only possible, but unstoppable. Who's leading the way? The US is betting big with the Artemis program, aiming to land humans on the Moon and create a lasting presence. Their secret weapon? The Lunar Gateway. Not to be outdone, China and Russia are teaming up for the International Lunar Research Station, a futuristic outpost right on the Moon's surface. Together, they're also building satellites and space stations to create a communication web around the Moon. And the European Space Agency, they're launching the Moonlight Initiative, setting up a communication and navigation system that'll keep everything connected, like a space-based internet between Earth and the Moon. Why does this matter? This isn't just about exploration. Cislunar Space is about building the future, new industries, new opportunities, and new ways of living. From lunar mining to space manufacturing, the infrastructure we're building today will launch humanity into an era of limitless potential. Cislunar Space is just the beginning, the first step toward Mars, the asteroid belt, and beyond. What we build today will shape the future of humanity in space, and maybe, just maybe, the future of human civilization itself. Building space infrastructure in cislunar space, such as space stations, communication satellites, and space factories, creates significant economic potential for several reasons. Space stations like NASA's Lunar Gateway serve as critical hubs for lunar exploration. By acting as staging points for missions, they reduce the cost and complexity of traveling to and from the moon. This makes it easier for governments and private companies to conduct regular lunar missions for exploration, resource extraction, or research. Economically, this reduces logistical barriers, opening up opportunities for industries such as mining lunar resources or conducting scientific research. Companies that can extract and use these resources may generate significant revenue streams, especially as lunar bases become more common. Cislunar infrastructure can serve as a launchpad for deeper space missions, including Mars expeditions or asteroid mining. Establishing refueling depots and repair facilities in cislunar space reduces the need to launch everything directly from Earth, lowering costs and enabling more ambitious missions. This opens up commercial opportunities for deep space exploration services and could lead to breakthroughs in industries such as space manufacturing or pharmaceuticals produced in microgravity, both of which could generate high returns. Microgravity offers an environment where materials can be produced with superior qualities compared to those made on Earth. For instance, fiber optics made in space can be nearly perfect, with fewer impurities, leading to significantly better performance for high-speed data transmission. On Earth, producing these with the same quality is much more expensive and challenging. Semiconductors and crystals grown in microgravity can be purer and more efficient than their Earth-made counterparts. This can improve electronics and communication devices, which are essential for modern industries and in high demand. Space-manufactured products like these can command a premium price in the market due to their superior performance and the difficulty of manufacturing them in space, creating high returns for companies that perfect these processes. Microgravity allows for the development of pharmaceuticals that are difficult or impossible to create on Earth. In space, biological processes such as protein crystallization happen differently, which can lead to the discovery of new drugs or more effective forms of existing drugs. For example, certain cancer drugs or treatments for rare diseases could be developed more effectively in space, where proteins form larger and more ordered crystals that allow scientists to better understand their structure. New treatments for diseases like osteoporosis or muscle atrophy, which mimic the conditions astronauts face in space, can be developed and tested in a more accurate environment. In the cislunar economy, communication is key. Companies like SpaceX, OneWeb, and Lockheed Martin are investing in satellite constellations to provide high-speed internet and communications across the Moon, Earth, and deep space. This internet in space will be vital for future missions and industries. And let's not forget space tourism. Companies like Virgin Galactic and SpaceX are leading the charge in making space accessible to the public. Soon, tourists could be taking trips not just to low Earth orbit but also to the Moon and beyond, creating a whole new industry. Nations, including China, see cislunar space as strategically critical. By controlling this region, they ensure not only economic dominance but also security over future space operations, potentially deterring conflict and protecting vital space assets. Governments are likely to invest heavily in securing their interests here, creating a defense economy tied to cislunar infrastructure. Controlling cislunar space gives nations geopolitical leverage over other countries. Just as dominance over key sea routes on Earth confers strategic and economic power, controlling space routes and infrastructure in cislunar space could enable a country to influence or even dictate the terms of access and operations for other nations and private companies. This leverage could be used in space diplomacy, where nations negotiate partnerships, resource-sharing agreements, or even peace treaties that hinge on cislunar space control. For instance, countries with established infrastructure could offer access to lunar bases or satellite networks to allies, while potentially restricting adversaries. As nations ramp up efforts to protect their interests in cislunar space, a space defense economy is likely to emerge, driven by demand for technologies that can secure and defend space infrastructure. This includes investment in space surveillance systems, anti-satellite defense measures, and autonomous repair and protection drones that can safeguard assets from both physical and cyber threats. These technologies will form the backbone of a space security industry, creating new opportunities for companies specializing in space defense. The rise of private space companies, both startups and established firms, has dramatically shifted the landscape of space exploration and industry. These players are not only expanding the possibilities of space missions, but are also poised to play a significant role in the cislunar economy. Private space companies began emerging in the early 2000s, driven by advancements in technology, a shift toward commercial partnerships, and a growing appetite for space entrepreneurship. Currently, companies like Astrobotic and Intuitive Machines are developing lunar landers to transport cargo, scientific instruments, and eventually, commercial payloads to the moon's surface. These efforts lay the groundwork for building lunar bases and establishing a sustained human presence on the moon. Their role is crucial in enabling resource extraction missions, which are expected to generate economic value through mining water ice, rare metals, and other valuable materials from the lunar surface. Another space company named Axiom Space is developing the world's first commercial space station, with plans to expand operations into cislunar space. Axiom's modular approach will allow for the creation of space hotels, research labs, and even space factories that can function in cislunar space. Sierra Space and NanoRacks are also developing space habitats and space stations. These companies see cislunar space stations as a hub for not only human habitation but also as places for space manufacturing and research, where microgravity can be harnessed to create new products and technologies. Lockheed Martin and Northrop Grumman are working on establishing communication and navigation networks in cislunar space. These systems will be vital for spacecraft traveling between Earth and the Moon, ensuring reliable communication and positioning even when spacecraft are on the far side of the Moon. Operating in cislunar space is still highly expensive and risky. Rockets need to be more reliable, and costs need to come down significantly to make operations sustainable. However, the economic potential is staggering. With private companies and governments collaborating on building the infrastructure of tomorrow, cislunar space is set to become a thriving hub of innovation, science, and commerce. Curious about how space will shape our future? Don't forget to like, share, and subscribe for more exciting insights into the cislunar economy and the next great space race.